solid if each atom only took one path. What keeps it solid is the interactions between different instances of the same atom in different universes. That is what makes for rigidity. It's also for what makes permanent magnets. It's also the reason that we can have amplification of signals. It's the reason that we can see stars.
Now, clearly that is not a common accepted view.
That is, well, I think all physicists who look at these phenomena would agree that quantum theory is needed to explain those phenomena.
Yes, that's
but
right.
They would not express quantum theory in terms of parallel universes.
For example, the solidity of matter could be explained by the exclusion principle, because things just can't occupy the same spot, and so
yes.
so it seems rigid when in fact it's mostly space.
Yes, so that's a good example. So if we take the exclusion principle and express it in its true quantum theoretic terms, it says that a sum of certain terms, of a vast number, exponentially vast number of terms, has to equal some other exponentially vast number of terms. And that is saying that each one of these things, if it represents reality, represents a different history of the atoms, and they are affecting each other.
That probability interpretation. So once you realise that, then really entanglement is just what you get when you consider this property that quantum systems can do two things at once, and then you think about more than one quantum system. So we had the electron that could be here and there at the same time. So now suppose I've got two electrons, and the joint state of the two electrons is they're both on the left and they're both on the right at the same time. And now as you ask, where's the first electron? You can't say it's on the left, you can't say it's on the right, you can't even say exactly that it's left and right at the same time. All you can say is what it's doing relative to what the other electron's doing.
Okay.
Or you can give a joint description of what both electrons are doing, and that's entanglement. And it's central to many worlds, because you remember when I was talking earlier about how I end up doing two things at once and you end up doing two things at once, but they're all correlated. Entanglement is what makes that happen. So you can't talk separately about my state and in the quantum any world situation, you can't talk separately about my state and your state and the cat state. All you can talk about is our joint state. So the joint state of you and me and the cat is cat dead, I see cat dead, you hear me say cat dead, plus cat alive, I see cat alive, you hear me say cat alive at the same time. And it's because of that that the language of worlds makes sense. If all the objects in the world were independently doing two things at once, you'd just have a sort of chaotic soup. You wouldn't have many worlds.
So you're saying entanglement kind of imposes coherence on the different worlds, or?
Yeah, I mean, it's ironic to use that word because decoherence is exactly the word we use to describe it. But yeah, entanglement is what makes the world structure happen.
I mean, otherwise it would be nonsensical if, well, I mean, it's almost the definition of what a single world is, that there is coherence in my sense of the term, and you're saying that is due to entanglement?
That's exactly right, yeah.
So entanglement is the glue that, at any given point, is holding all this together?
That's right. So, I mean, Schrödinger famously said, I think it's Schrödinger, that he used to think what was mysterious about quantum mechanics was superposition, which is the here and there at the same time thing, and eventually he decided, no, entanglement is the real mystery of quantum mechanics.
But, you know, usually when people argue with Dennett about this, they talk about, you know, they take for granted the material world. And they say, well, yeah, but okay, I get the way the material world works, but it's not that easy to get from there to consciousness. You're questioning his kind of argument in a different way, right? You're saying, whoa, before you casually refer to the material world, as, you know, as if we really know that is like this solid stuff. Let's examine that premise.
Right, exactly. What I'm saying is that, you know, for someone to be a hardcore materialist, there is a certain level at which they have to ignore the fact that our understanding of matter, that you know, the last 100 years of our probing matter, that in spite of the enormous progress we've made, and in some sense because of the enormous progress we made, we really don't know what matter is, and particularly we don't know what our role is in articulating exactly what matter is. And so, you know, there's many weirdnesses, but it's around this thing called the wave function. And the wave function is the thing that describes whatever quantum system you're interested in. So let's say you have a box, and the box has a cat in it, and the cat, and there's a jar of poison which is connected to a radioactive atom, which is a quantum system, which is going to decay or not decay, right? So if the box is closed, the wave function for the cat, right? Now this is imperfect for a lot of reasons, but this is what we use. The wave function for the cat has two parts. The cat is dead because the vial, cracked and the poison went out, and the cat is alive because the radioactive atom never decayed. And what this mathematical object, which is fundamental to quantum mechanics, which is the wave function, says both are true. They both, the mathematics has both of them existing at the same time.
Until you open the box and look.
And when you open the box, that is what we call the measurement problem. Because at that moment, this mathematical thing suddenly, arbitrarily drops from having two things to one thing. You either see the live cat or the dead cat. Now, what's the problem with that? Physicists like to believe that their math is actually about the world, right? If I write down the equations for an electromagnetic wave, a radio wave traveling through space, I think there really are radio waves. So that math actually describes the thing in the world. But now, what is this thing called the wave function? Because it's got this weird property that, before I looked, all possibilities are equally possible, or even worse, depending on how you look at it, all possibilities exist. It's as if the cat is dead and is alive.
And that is actually one interpretation that we'll get to of what quantum physics means, that there literally remain two cats going forward in two different worlds. That's the so-called many worlds interpretation. And actually, by the way,
Einstein literally used the word spooky in the context of quantum physics for these kinds of processes that, as you say, he thought were clearly an emergent feature of the math, but obviously not a feature of reality. And for that reason, he was like, okay, there's a mismatch between what the math of quantum mechanics says and what reality actually allows to happen. And in the end of the day, he went to his grave thinking that there was a deeper theory that, if we could find it, would do a kind of end run around quantum mechanics, showing that all of these weird features were merely an artifact of the fact that we didn't have the deep understanding as yet. But in the time since, we found that all of the things that bothered Einstein profoundly, all of them have been borne out by observation and experiment. So
I don't buy that either. I buy an infinite number of universes, each of which is static, frozen, like a still frame in a motion picture. And it is your mind that moves through these universes.
Okay,
producing what you perceive. And the route you take through this infinite labyrinth of universes can be different from the route that somebody else takes. So what you perceive can be different from what they perceive.
so how does this whole concept of there being an infinite number of universes even come about? Most people see what they consider to be a reality with their eyes, and what they see that's real, and that's there, and that's the universe. How do we get multiple universes from the one that we actually visualize?
From quantum physics, from the concept of quantum physics that requires the universes to be splitting at a fantastic rate into multiple copies of themselves. Of course, in that theory, you can only be in one universe, so you don't notice this happening. But quantum physics says it happens, and there is some experimental data to support that, as well as the fact that the computer industry is now even planning on having computers that dip briefly into an adjacent universe to speed up the computation process.
Because it is obvious that throughout time, miracles have occurred, and people have experienced them, and people have experienced healing from cancer, and I think that if they were able to somehow access the universe in which they didn't have it, then that certainly sort of works. It works for me. It's the question as we continue to talk about this is just how it all gets put together. And I'm observing myself as I'm thinking now, because I'm thinking, okay, well, gee, I can go here, I can go here, I can go here, and I guess each of those would be somewhat of a different universe that I could enter into. Would I be correct?
Okay. The light, you can determine it. I'd like to give you a little different scenario than that.
Okay.
Let us assume, and this is proven science, that a star a million light years away, it takes light a million years to get here from that star.
Mm-hmm.
It emits a photon. An atom on that star emits two photons simultaneously, as tends to be the case, one going in one direction, one going in the other direction.
Okay.
That photon is polarized light, vertically polarized, horizontally polarized at an angle, but it's polarized light. When you can change the polarity of polarized light very easily by passing it through a series of polarizing filters till you get it from vertical to horizontal or vice versa. If you just put up one polarizing filter at right angles to the polarity of the light, it doesn't come through. But if you can turn that photon. Now, here's the catch. When that photon hits, and you turn that photon, the photon that went off in the other direction a million years ago simultaneously turns to match it.
Mm-hmm.
Yeah.
Mm-hmm.
Reality can be changed, and that's faster than light, by the way. That's faster than the speed of light. That's an infinitely fast transition at a distance of, in this hypothetical, 2 million light years. That's a long way off. A light year is 5,880,000,000,000 miles. A brilliant mind in quantum physics says the universe does not exist out there independent of us. We are inescapably involved in bringing about that which appears to be happening. We are not only observers, we are participants. In some strange sense, this is a participatory universe.
That would be John Archibald Wheeler.
Yes, it would.
Yes. Yeah. The thing that, the discussion and what we're talking about is great. And one of the things that I would like for listeners to really get out of it is what is indeed what they can draw upon. I mean, let's take, for instance, somebody who is struggling for employment or struggling to make ends meet or struggling to find who they are in this world. Well, somewhere out there in the multiverse, there is a static universe, which hopefully is contiguous with theirs, where they are doing quite well, where they are taking care of themselves, or where they know what their purpose in life is, and they're going about it. And so, therefore, it's very possible for them to, through whether it's prayer or whether it's through some of the other rituals, make their connection with that. How does this whole concept of there being an infinite number of universes even come about? Most people see what they consider to be a reality with their eyes, and what they see, that's real, and that's there, and that's the universe. How do we get multiple universes from the one that we actually visualize? The concept of quantum physics that requires the universes to be splitting at a fantastic rate into multiple copies of themselves. Of course, in that theory, you can only be in one universe, so you don't notice this happening. But quantum physics says it happens, and there is some experimental data to support that, as well as the fact that the computer industry is now even planning on having computers that dip briefly into an adjacent universe to speed up the computation process. That sounds really far out, actually.
Yeah, I know, but I've read about that, and apparently it's happening. Assuming these parallel universes exist, I think you have there not only parallel universes forking or splitting into the future, but also into the past, with different pasts being possible, different past histories.
So then the future can change the past.
Now that's proven scientifically and experimentally with the aspect experimented in Paris, France, with light. Einstein came up with, and he wasn't comfortable with it, the causal order postulate that said for event A to cause event B, event A has to happen earlier in time than event B. And that has now been experimentally disproven at the quantum level.
Okay. So you're saying that event A doesn't have to happen earlier than event B
To cause event B.
to cause event B.
Correct.